Okay, so in example 1, this says our objective for example 1 is to find the maximum value of, and it gives us z equals 3x plus 2y. You have absolutely no idea what that means right now because there's not a word problem that goes with it, but when we put the words in, it'll make a lot of sense. Right now, we're just going to have to find the maximum value of this equation. They call this equation the objective function. So those words over here is just telling you that's what this thing is called. This is the objective of the whole problem, is to find the maximum value of this, subject to the following constraints. So we're going to have some constraints on this. The constraints that we will use will be x is greater than or equal to 0, y is greater than or equal to 0, x plus 2y is less than or equal to 4, and x minus y less than or equal to 1. Those are all the constraints. So these are what we're going to graph, right? X is greater than or equal to 0. What kind of line is x is greater than or equal to 0? What kind of line? All lines are straight, dear. That's my favorite thing to say because I have it. People say it every single time that we're talking about what kind of line. Nope. Vertical. When it's x equals, it's vertical because that's the one that does not have a slope. So x is greater than or equal to 0. We're going to start here at 0, and if x is greater than, which direction am I going to shade? To the right. Y is greater than or equal to 0, so that's the horizontal straight line. Do you guys still have your straight edges? Because I should probably get mine back out. Y is greater than or equal to 0. We're going to go above this line. So far, before I do any other equations, my region that's going to like overlap, where it's going to be shaded, is now down to what part of this graph? Just first quadrant. Perfect. Quadrant 1. So nothing is going to be shaded. I mean, stuff could be shaded, but when we have that overlapped final region, none of it's going to be in the other quadrants. And that's going to pretty much be the same for the problems that we do tomorrow when they're real-life application. We've got a third constraint. We've got x plus 2y less than or equal to 4. So you can either change that into y equals mx plus b form, or we can do x and y intercepts. I'm going to do x and y intercepts. So my x-intercept, if I take out y, I'm going to get x equals 4. So 4, 0. My y-intercept, if I take out x, I'll get 2y equals 4. So y is 2, 0, 2. Plot those. Do I need the slope? Also. If I did need the slope, what is the formula for the slope? M equals what? Negative a over b, yeah. If you did need the slope, I don't need it for this. I'm going to connect these, and all of these look like they are solid lines. I'm going to connect these, but I'm not even going to bother to go past the first quadrant because I know it's only going to be in the first quadrant due to my first two constraints. How do we find out which side of the line is shaded? Michaela, what should I do to figure out the shading? Which point? Well, one that's not on the line. It can be on the triangle, but it can't be on the line. So give me your choice. 0, 1. Okay. How about an easier one? 0, 0 is okay. Yes, I think because you were getting like, well, I can't use these because of the other two constraints, but that doesn't affect where this one gets shaded. I could use this point way down here if I want. As long as it's not on this line, I can figure it out. So I'm going to use 0, 0. You can use 0, 1 if you want, or 1, 0, whatever you said. I'm going to use 0, 0. So we'll have 0 plus 2 times 0 less than or equal to 4. Is that true? 0 less than or equal to 4. Is that true? Yes. So 0, 0 does get shaded. It will be shaded this direction in a moment. If you want to shade that because you do them really light and then just color in dark the final answer, that's fine. I'm just going to color in what the final answer looks like. And then the last one is x minus y less than or equal to 1. So if I do that with x and y intercepts, let's see, x would be 1. Y, negative y equals 1, so y would equal negative 1. And just by these 2 points, I can figure out the slope is positive 1, so I can keep going. But the only part that really matters is the part in the first quadrant. Now, when I test a point for this, anybody have a suggestion? Kia, what point would you test? Okay, 0, 0. I'm going to plug it in. 0 minus 0 less than or equal to 1. True. So we will shade towards 0, 0. It will be that direction. When I go and I overlap everything and I see what it all has in common, this is the final shaded region. So that kind of stuff we've already done. Next thing we've already done is we're going to find the vertices of the shaded region. So this is a quadrilateral. There will be how many vertices? 4. Let's see, 0, 0 is one of them. Looks like 1, 0, 0, 2, and then this last one, because I was able to graph these lines and the slope all works out that there actually is a dot right here, I'm pretty positive that this one is 2, 1. But I'm going to warn you right now, it's not so obvious every single time. So I'm going to pretend for a second that this one was not obvious. I'll pretend, okay? If I could not tell what that point was, how could I find what that point was? Plug what in? If I don't know the ordered pair 2, 1, if I'm looking at, maybe I'm counting 50s this way and 30s this way, and I'm trying to figure out where this crosses. If I can't look at it and tell where it crosses, what can I do? Gauge.
Did you take the 2 from the x-axis and plug it into the equation and solve it for y?
But I don't know if it really is at 2. I'm just saying right now, I'm not sure. And maybe I drew my graph really terribly. What other method do we have for solving the point in common between 2 lines besides graphing? What is our other method? Sydney? Substitution or elimination. If you can't tell, and there's going to be some that you can't tell. If you can't tell where they cross, you're going to use the other stuff we learned. Substitution or elimination. So I'm going to go through that quickly with equations 3 and 4. Right here. When you look at the way these are set up, would you guys use elimination or substitution? Just curious. I heard a boy say elimination. I heard a girl say, I don't know what it was though. What, Eddie? Oh, you said the elimination? That's what I would use. There's not a wrong answer. Just curious what you guys thought. Was that you, Madison, that said it? Oh, some girl said it. Okay. I would use elimination. I'd probably multiply maybe the second one by -1 first. So I would have x plus 2y equals 4 and negative x plus y equals -1. Before I go any further, why am I using equal signs? No idea. Maybe. What am I trying to find here? Shivani, what am I trying to find? The point where what? The point where they meet. Is that what you said? Yeah, I'm trying to find the point where they are what? Equal to each other. I'm not trying to do anything with shading this moment. I'm just trying to find where do these graphs cross? Where are they equivalent? So that's why I'm using equal signs. That's also why I used equal signs in the x, y intercept, because it doesn't really matter where it's shaded when I'm finding the points. The only part that matters about where it's shaded is when I find out where it's shaded. That's the only time I need the inequalities. We're deciding where it's shaded. The rest of the time you can use equals for everything. So I'm using equals. I'm going to add those together. I get 3y equals 3, so y equals 1. Now I know what y equals. What do I do with y? Plug it in. Maybe I plug it into 4. So I have x minus 1 equals 1. No? Yes. X equals 2. And then I can check it in equation 3 just to make sure. So there will be questions where you will have to do this. We just had the discussion about it right now. You have 3 methods of finding where 2 things cross. Graphing, elimination, substitution. All right, so that we have our 4 vertices. Now it says test the vertices. So what we're going to do is in this region, these are all the solutions to this system. All of these are solutions to this system. But they only want one answer. Everything colored here is a solution. And using this method, one of the solutions will be, I can't say that 100%. Most of the time, one of these solutions will be the vertices. One of the vertices, okay? Which is why we get all the vertices and test it. I can give you an example where it wouldn't be. But you test it in the objective function. So what we're doing is trying to find out which vertice gives us the maximum value for z when we plug in x and y. So I'm going to plug in 0, 0. We're going to do z equals times 0 plus 2 times 0, and you guys get 0, right? We're going to test 1, 0. Z equals 3 times 1 plus 2 times 0, and that's 3. Z equals 3 times 0 plus 2 times 2, and that's 4. And then z equals 3 times 2 plus 2 times 1, and that's 8. So we test each vertex, and we see which one gave us the max value. And what is the max value? So the max value would be which value? The maximum number would be 8. And which ordered pair gave us 8? So you would say the max value of 8 is at 2, 1. In the assignment, it also asks for the minimum value, which this example doesn't have minimum value. But if I wanted to know the minimum value, what would be the minimum value and where would that be? Min of what? What's the smallest number? 0. At what point? 0, 0. Okay. And then I just said there is a time where one of these vertices won't give you the answer. I'm just going to sketch it really fast. This is like the final shaded region. Oh, sorry, I was off a little bit. If that's the final shaded region and you find these vertices, when you plug these in, neither of these will end up giving you a max value because the entire shaded region goes on forever and ever and ever and ever. So if you have something like this that goes on forever and ever and ever and ever, can I ever plug in the biggest number? No. So this would like have no maximum value. I know there's one in homework that looks like that. I had people ask me about it today. Since you guys don't have XH after I saw you and did this, I just wanted to show you that can be a possibility. Okay? Your assignment is 4 questions. Looks like a perfect opportunity for some of you to go do that video or do it the first time. Your assignment is written on Canvas. and the book length is on Canvas. I just have to give you 4 graphs. Okay? 4 questions. You guys have 9 minutes now, and then this will be due tomorrow.